Alright, here we go. So we want to basically sketch this curve, and we're allowed to use whatever we want really. So I'm just going to go ahead without reading the question. Okay, f of x equals x to the power of 4 minus 4x cubed. Alright, so let's just have a look at each of the bits of information we've got. So if I factorize that, I think that is correct. Then you can, of course, from that information, you can find your x-intercepts. So we know our x-intercepts occur at when f of x equals 0. So when x equals 0 and 4. So I might put those in first. Let's say 0, and it's not to scale, but let's make that 4 there. Alright, so 0 and 4 are our x-intercepts. Alright, so then what do we get from f dash of x? So going back to that, I get 4x cubed minus 12x squared. And another way of saying that is 4x squared times x minus 3. Is that right? So 4x cubed minus 12x squared. Yep. Alright, so when, what does this help us to do? This helps us find stationary points, of course, when f dash of x equals 0. So you can see from that one we would get a 0 and a 3. So a 0 and 3, and then of course what I would do is go, alright, so 0 and 3, and then how do we find this? Well, that's the y value, so back into f of x. So when I sub 0 back into f of x, I've got 0 times negative 4, so that's 0. And when I sub in 3, I have 3 cubed, so that's 27, times negative 1, so negative 27. Alright, so I've got my two stationary points as well. Two stationary points. Now, what I would do then is find the nature of those points. Pretty straightforward. If you think about it, which is always a funny thing in this course, that you have to kind of show it. If it just says sketch the curve, then you're just sketching the curve. But if it's scaffolded, broken up, or if it says show that, you really should make sure you put these things in even when they're obvious. So often you'll see I'm subbing in my head without actually subbing in to these equations. If I knew there were marks for that, I would definitely show it. And same here, I really don't need to sub into f double dash of x to find whether they're maximum or minimum turning points. It's pretty obvious. So 0, 0 is here, and 3 minus 27, let's put it down here. Again, not to scale. 3 minus 27. Clearly, to go from that point to that point, this is going to have to be a minimum, and to cut back through up here, sorry, bad picture as usual, it's going to have to be a minimum turning point down there. Yeah. Now, if we have a look at f double dash of 3, where x equals 3, actually I've got to find double dash first. That would be a good idea. Alright, so double dash, we would get 12x squared minus 24x, and another way of saying that is 12x, x minus 2. So you can see, first of all, if I just sub, alright, I'll do that now. So if I sub in 3 here, what am I going to get? I'm going to get a 36. I'm subbing into this bit here, just easier. So 12 threes, I think, are 36, and 3 minus 2 is a 1. So I'm going to get a 36, which is positive, which means you've got a minimum stat point. That's min stat point. Sorry about the writing. Alright, so if I had to kind of show it, then I would put numbers in. Often I don't even put that, I just go, oh, it's positive, or it is greater than 0. But if I know they want, if they're marking for that working, I'll actually put a number in, which is annoying, yes. Alright, and then so what about f double dash of 0 is a little bit, I mean, we could guess, but a little bit more, more information needed. But another thing you can do is just have a look at your f double dash of x, and remember f double dash of x, where it equals 0, what does that tell us? That tells us potential points of inflection, potential. So possible points of inflection, and you can see that 0 is a possible point of inflection, and also from this bracket 2. All right, so that makes sense. So you know, here we're going from happy, and let's say 2 is here, again not to scale. So maybe here it turns from happy to sad, or really like that, so that there is a turning point there. We could check either side. So it looks like at 0, 0 it's going to be a maximum turning point, but we really, you know, need to check that. Now, if I put in 0 into there, you know I'll get 0. So no, it's not a maximum turning point. So what could it be then? All right, so if you have a look either side of 0, well, you can do either, but concavity or gradient, doesn't matter which one you use really. But if we look at how concavity changes either side of 0, so 0 minus 1, we already know the concavity at 2. Anyway, we'll just put 1 in anyway. So that's x, and this is our double dash. So if I had to set it out, really you can just do it in your mind, of course. So we know it's 0 at 0. This is f double dash, remember what you're looking at. If I look at x equals 1, so here we're putting it here. So we'll get 12 times negative 1, because 1 minus 2 is negative 1. So we get negative 12. I'm actually going to put the number in there. When I sub in negative 1, I'm going to get, so that's going to be a negative 12 and a negative 3. So that's a positive 36. So you can see it's got a happy concavity, so it does change from happy to sad, so it is a point, therefore it is a point of inflection, because there is a change in concavity. So the fact that f double dash of 0 equaled 0, f double dash of 0 equaled 0, that meant 0 was a possible, x equals 0 is a possible point of inflection. Then we check either side. Yes, there is a change in concavity, so it's a definite point of inflection. If you think about it, it's going from happy to sad, and there's the sad bit we already drew in. So happy, so it must be going like this. It's looking like a kind of a negative cubic in that bit. And then, of course, our point of inflection at 2 occurred as well, so point of inflection at 0 and 2, and a minimum turning point at x equals 3. Now, we didn't really, if it just had sketched the curve, we could have figured that out by just having a look at when x is negative in the actual function. Here we go. If I just have a look at when x is negative, this is going to be negative, this is also going to be negative. Negative times negative is positive. So, you know, it's quite easy to see there that we are going to be up in this area. So it could not be a maximum turning point. So you've got all these different tools you can use to figure out points of inflection, gradients, just actual points and where they are, and it's really obvious if it's going from here to here and to here, then it's got to be, for example, that point's got to be a minimum turning point. So really just using all your tools.